Good morning, students. Today we will start the next topic, that is Avogadro's law, or it is also called Avogadro's hypothesis. But before studying Avogadro's hypothesis, first we will study Berzelius hypothesis. And according to this hypothesis, equal volume of gases under the same condition of temperature and pressure contain equal number of atoms. Once I will repeat, according to Berzelius hypothesis, equal volume of different gases under the same condition of temperature and pressure contain equal number of atoms. Mean, according to him, if there is n atoms in 1 liter of hydrogen, so again there will be n atoms in 1 liter of oxygen, provided that volume are measured under the same condition of temperature and pressure. According to this hypothesis, equal volume of gases under the same condition of temperature and pressure contain equal number of atoms. But later on, this hypothesis was found to be wrong. And you see, what is the error in this hypothesis, or what is the limitation of this hypothesis? So you see, we know the hydrogen react with chlorine, then hydrogen chloride is formed. And we know, according to Gay-Lussac's law that we have earlier studied, one volume of hydrogen react with one volume of chlorine, then two volume of hydrogen chloride is formed, and these volume are measured under the same condition of temperature and pressure, which also means that 1 liter of hydrogen react with 1 liter of chlorine, that 2 liter of hydrogen chloride is formed. Now if we apply Berzelius hypothesis, on this reaction, then we can say, if 1 liter of hydrogen contain n atoms of hydrogen, then there will be n atoms of chlorine in 1 liter of chlorine, and there will be 2n compound atom, or you can say molecules of hydrogen chloride in 2 liter of hydrogen chloride, which also means that n atoms of hydrogen react with n atoms of chlorine, then 2n molecules of HCl will be formed. And if we take 1 atom of hydrogen, so it will react with 1 atom of chlorine, then 2 compound atom, or we can say 2 molecule of hydrogen chloride will be formed. It means for the formation of 2 molecule of HCl, 1 atom of hydrogen and 1 atom of chlorine are required. And for the formation of 1 molecule of HCl, half atom of hydrogen and half atom of chlorine will be required. From this we can conclude half atom of hydrogen and half atom of chlorine will combine, then one compound of atom of HCl or one molecule of HCl will be formed. But we know atoms never combine in fraction. Atoms always combine in whole number ratio, they never combine in fractions. It means half atom of hydrogen can't combine with half atom of chlorine to form one molecule of HCl. And this is the error in Berzelius hypothesis. Because according to Berzelius hypothesis, half atom of hydrogen should react with half atom of chlorine and one molecule of HCl should be formed. Now this error in Berzelius hypothesis was removed by Avogadro. And now according to Avogadro's hypothesis, equal volume of gases under the same condition of temperature and pressure contain equal number of molecules. यानी Avogadro replaced a single term, that is atom by molecule, because in Berzelius hypothesis equal volume of gases under same condition of temperature pressure contain equal number of atoms, but according to Avogadro's hypothesis equal volume of gases under the same condition of temperature pressure contain equal number of molecules. Suppose we have 1 liter hydrogen at NTP and 1 liter of oxygen at NTP. NTP is a normal temperature and pressure. Normal temperature is 0 degree Celsius or 273 Kelvin and normal pressure is 1 atmosphere. Now both gases have equal volume and same condition of temperature and pressure. Then if there are X molecules of hydrogen in 1 liter of hydrogen, then there will be X molecules of oxygen in 1 liter of oxygen. Yani according to Avogadro's hypothesis, same volume of gases under the same condition of temperature pressure contain same number of molecules. An equal volume of gases under the same condition of temperature pressure contain equal number of molecules. And likewise, if we take 1 liter of ozone at same condition, that is NTP, so there will be X molecules of ozone. These are 3 different gases: hydrogen, oxygen and ozone. If we take their equal volume under the same condition of temperature and pressure, they all contain same number of molecules. So this is Avogadro's hypothesis, or it is also known as Avogadro's law. And this hypothesis we can say is correct, and we can prove it from same example. Like hydrogen react with chlorine, then we know hydrogen chloride is formed, and from Gay-Lussac's law, 1 volume of hydrogen react with 1 volume of chlorine, then 2 volume of HCl is formed. 2 volume of hydrogen chloride is formed. And we can say 1 liter of hydrogen react with 1 liter of chlorine, then 2 liter of hydrogen chloride will be formed. And if we apply Avogadro's hypothesis, so according to Avogadro hypothesis, equal volume of gases contain equal number of molecules under the same condition of temperature and pressure. Then if there are n molecules of hydrogen in 1 liter of hydrogen, so there will be n molecules of chlorine in 1 liter of chlorine, and there will be 2n molecules of HCl in 2 liter of HCl, which also means that n molecule of hydrogen react with n molecule of chlorine, then 2n molecule of hydrogen chloride will be formed. And if we take n as one molecule, then one molecule of hydrogen will react with one molecule of chlorine, then two molecule of HCl will be formed. And for the formation of one molecule of HCl, half molecule of hydrogen and half molecule of chlorine is required. And we know hydrogen is diatomic gas. One molecule of hydrogen contains two hydrogen atoms. Then half molecule of hydrogen will be one hydrogen atom, and half molecule of chlorine will be one chlorine atom, as chlorine is also diatomic. One molecule of chlorine also contains two chlorine atoms. Then half molecule of chlorine will be one chlorine atom. So we can say one hydrogen atom, one chlorine atom combined, then one molecule of hydrogen chloride is formed. Mean the error which was in Berzelius hypothesis now has been removed by Avogadro. So according to Avogadro's hypothesis, equal volume of gases under the same condition of temperature and pressure contain equal number of molecules. I can repeat this example. Hydrogen when react with chlorine, hydrogen chloride is formed, and according to Gay-Lussac's law of combining gases volume, one volume of hydrogen react with one volume of chlorine, then two volume of HCl is formed, or we can write 1 liter of hydrogen react with 1 liter of chlorine, then 2 liter of HCl is formed. And now if we apply Avogadro's hypothesis, so I can say 1 liter of hydrogen may contain n molecule of hydrogen, then 1 liter of chlorine will also contain n molecule of chlorine, and 2 liter of HCl will contain 2n molecule of HCl. And if we take n as one molecule, so one molecule of hydrogen will react with one molecule of chlorine, then two molecule of HCl will be formed. Or for the formation of one molecule of HCl, half molecule of hydrogen and half molecule of chlorine will be required. And we know half molecule of hydrogen will be equal to one hydrogen atom, half molecule of chlorine will be equal to one chlorine atom, and one hydrogen and one chlorine atom will combine to form one molecule of HCl. Now we will discuss applications of Avogadro's law or Avogadro's hypothesis. You will write down applications, or you will write importance of Avogadro's law, or you can write Avogadro's hypothesis. And first application of Avogadro's hypothesis is to determine a relation between vapor density of a gas and its molecular mass. Yani on the basis of Avogadro's hypothesis, we can determine a relation between vapor density of gas, and vapor density of a gaseous substance and its molecular mass. So first of all, what is vapor density? So we can say it is the ratio of density of a gas, or you can say gaseous substance, to the density of, it is the ratio of density of a gas, and you can say, and it is the ratio of density of a gas at given temperature and pressure and density of hydrogen at same temperature and pressure. Yani we can write vapor density will be equal to density of a gas at given temperature and pressure divided by density of hydrogen gas at same temperature and pressure. Yani when we compare the density of a gas with the density of hydrogen gas under same condition of temperature pressure, it is called vapor density. And from here I can say vapor density is number of times a gas is heavier than hydrogen gas. And vapor density can also be defined as the number of times a gas is heavier than hydrogen gas at same temperature and pressure. And you see, vapor density will be a unitless quantity, as it is the ratio of two densities. Density of gas can be taken in gram per liter, so density of hydrogen will also be in gram per liter. So vapor density has no unit, it is just a number, and this number tells how many times that gas is heavier than hydrogen gas. Now we will derive a relation between vapor density of gas and its molecular mass. So we will start from here. Vapor density is equal to density of gas at a given temperature and pressure divided by density of hydrogen gas at same temperature and pressure. So we know density is a mass per unit volume. So I can say mass of 1 liter of the gas at given temperature and pressure divided by mass of 1 liter of hydrogen gas at same temperature and pressure. Because density is a mass per unit volume. So mass of 1 liter of gas will be density of gas, and mass of 1 liter of hydrogen will be density of hydrogen. And now I can write mass of n molecules of gas divided by mass of n molecules of hydrogen gas. From where this I written, we know equal volume of gases under the same temperature and pressure contain equal number of molecules. So if there are n molecule of gas in 1 liter of gas, so there will be n molecules of hydrogen in 1 liter of hydrogen. So we can compare mass of n molecule of hydrogen to the mass of n molecule of hydrogen. And I can write here mass of 1 molecule of gas divided by mass of 1 molecule of hydrogen. And that further I can write vapor density will be equal to molecular mass of gas यानी mass of one molecule of gas can be called molecular mass of gas divided by molecular mass of hydrogen. So I can write here molecular mass of gas or gaseous substance divided by molecular mass of hydrogen, that is 2. It means vapor density of a gas will be equal to molecular mass of gas divided by 2. And this formula can be applied to any gas or a gaseous substance. So this is the relation between vapor density and molecular mass of a gas. And vapor density will be equal to molecular mass of gas divided by 2, or we can write molecular mass of gas will be equal to 2 into vapor density. Once I can repeat it, you know the vapor density is density of gas at given temperature and pressure divided by density of hydrogen gas at same temperature and pressure. And density is mass per unit volume. So I am writing here mass of 1 liter of gas at given temperature and pressure divided by mass of 1 liter of hydrogen gas at same temperature and pressure. And now if we apply Avogadro's law, so 1 liter of gas may contain n molecule of gas, then 1 liter of hydrogen gas will contain n molecule of hydrogen. So I can write mass of n molecule of gas divided by mass of n molecule of hydrogen gas. Then I can write mass of 1 molecule of gas divided by mass of 1 molecule of hydrogen. And mass of 1 molecule of gas can be written as molecular mass of that gas divided by molecular mass of hydrogen. And we know the molecular mass of hydrogen is 2. So vapor density will be equal to molecular mass divided by 2, and molecular mass of gas will be equal to 2 into vapor density. For example, oxygen has molecular mass 32. So vapor density of oxygen will be 32 by 2, yani 16, which means that oxygen is 16 times heavier than hydrogen under the same condition of temperature and pressure. Yani oxygen is 16 times heavier than hydrogen. Likewise, if we have gas like sulfur dioxide, its molecular mass is 64 and its vapor density will be 64 by 2, yani 32. So I can say sulfur dioxide is 32 times heavier than hydrogen. Yani if we have 1 liter of sulfur dioxide and 1 liter of hydrogen under the same condition of temperature and pressure, then 1 liter of sulfur dioxide will be 32 times heavier than 1 liter of hydrogen. The first application that to determine a relation between vapor density and molecular mass of gas we have done. Now the second application, that is to determine a relation between molecular mass of a gas and its molar volume at NTP. Yani now we will decide a relation between molecular mass of a gas and molar volume of that gas at NTP. Molar volume means volume occupied by 1 mole of gas, and NTP means here normal temperature and pressure, and normal temperature is 0 degree Celsius, or you can write 273.15 Kelvin, or you can write 273 Kelvin only. And normal pressure is 1 atmospheric pressure, that can be written 76 centimeter of mercury column, or pressure exerted by 760 millimeter of mercury coulomb. So now we will decide a relation between molecular mass of gas and its volume at NTP. Now you see, we have derived the relation molecular mass of gas equal to 2 into vapor density of gas. In previous application, this relation we have derived. Yani molecular mass of gas is equal to 2 into vapor density. And vapor density is density of gas at NTP we can take divided by density of hydrogen gas at NTP. NTP means normal temperature and pressure. So I can write here 2 into mass of 1 liter of gas at NTP divided by mass of 1 liter of hydrogen gas at NTP. And you have to remember, mass of 1 liter of hydrogen at NTP is 0.089 gram, near about. Yani 1 liter of hydrogen gas at NTP weighs 0.089 gram. So I can write here 2 into mass of 1 liter of gas at NTP divided by 0.089, and 2 divided by 0.089 into mass of 1 liter of gas at NTP, and that can be written 22.4. 2 divided by 0.089, 2 divided by 0.089, decimal we will remove, so it will be 2000 by 89, and you solve it, it will be almost 22.4 into mass of 1 liter of gas at NTP, or we can write mass of 22.4 liter of gas at NTP. So here you see, this is the relation between molecular mass of gas and volume occupied by 1 mole of gas at NTP. So molecular mass of any gas is the mass of 22.4 liter of gas at NTP. It means if we have 22.4 liter of hydrogen at NTP, it will be 2 gram. And if we have 22.4 liter of oxygen at NTP, it will be 32 gram. Yani 22.4 liter of any gas at NTP is weighing equal to its gram molecular mass, or you can say molar mass of the gas. This is the relation between molecular mass of gas and its molar volume at NTP. Now, the third application, that is to determine atomicity of elementary gases. First of all, what the meaning of elementary gas? Mean a gaseous element which is a gas, like we know hydrogen, nitrogen, oxygen. These are elements, and they are gaseous element at normal room temperature. And now what the meaning of atomicity? So we will say the number of atoms of an element present in its one molecule. Here you can say the number of atoms of an element in one molecule of the element is called atomicity of the element. Like we know, hydrogen is diatomic, which means that there are two hydrogen atoms in one molecule of hydrogen. Nitrogen is also diatomic. In one molecule of nitrogen, there are two nitrogen atoms. Oxygen is diatomic, which also means that there are two oxygen atoms in one oxygen molecule. Ozone is triatomic. In one molecule of ozone, there are three oxygen atoms. Phosphorus is tetraatomic. In one molecule of phosphorus, there are four phosphorus atoms. And sulfur is octaatomic. It means there are 8 sulfur atoms in one molecule of sulfur. Likewise, these noble gases are monoatomic. Helium, neon, argon, krypton, xenon, radon, they all are monoatomic gases. Monoatomic means they exist in the form of single atom or their molecule contain only one atom. So noble gases are monoatomic. Hydrogen, nitrogen, oxygen are diatomic. Likewise, fluorine, chlorine, bromine, iodine, they are also diatomic. Ozone is triatomic, phosphorus tetraatomic, and sulfur is octaatomic. So atomicity is the number of atoms present in one molecule of the element. And now we will decide a relation between, we will determine the atomicity of elementary gases. So here you see, I will take the example, hydrogen react with chlorine, then hydrogen chloride is formed. And we know according to Gill-Lussac's law of chlorine, then 2 volume of HCl is formed. And 1 liter of hydrogen react with 1 liter of chlorine, then 2 liter of HCl is formed. And if we apply Avogadro's hypothesis on this reaction, so I can say n molecules of hydrogen react with n molecules of chlorine, then 2n molecules of HCl are formed. And I can write 1 molecule of hydrogen react with 1 molecule of chlorine, then 2 molecule of HCl is formed. And you see, for the formation of 1 molecule of HCl, we need half molecule of chlorine and half molecule of hydrogen. And we know in 1 molecule of HCl there is 1 hydrogen and 1 chlorine atom. And this hydrogen atom comes from half molecule of hydrogen. It means half molecule of hydrogen is equal to 1 hydrogen atom. And we know HCl molecule contains 1 chlorine atom that come from half molecule of chlorine. So half molecule of chlorine will be equal to 1 chlorine atom. If half molecule of hydrogen is 1 hydrogen atom, so 1 molecule of hydrogen will be equal to 2 hydrogen atom, or I can say hydrogen is diatomic. Again you see half molecule of hydrogen is equal to 1 hydrogen atom. one molecule of hydrogen will be equal to two hydrogen atom. It means one molecule of hydrogen contain two hydrogen atom. So hydrogen is diatomic and we should write it H2. Likewise, one chlorine atom is equal to half molecule. Yani half molecule of chlorine contain one chlorine atom. So one molecule of chlorine will contain two chlorine atom. So I can say chlorine is also diatomic and it should be written as Cl2. It should be written as Cl2. From this example, it is clear that hydrogen is diatomic gas, chlorine is also diatomic gas. You can note down it. We can take one more example. We know hydrogen react with oxygen, then water vapors are formed. And according to Gill-Lussac's law, two volume of hydrogen react with one volume of oxygen, then two volume of water vapor are formed. That is practically decided. Any two volume of hydrogen always consume one volume of oxygen, then two volume of water vapor are formed. So I can say 2 liter of hydrogen react with 1 liter of oxygen, then 2 liter water vapors are formed. And if we apply Avogadro's hypothesis or Avogadro's law, so I can say 2 liter of hydrogen may contain 2 n molecules of hydrogen. 1 liter of oxygen will contain n molecules of oxygen, and 2 liter of water vapor will contain 2n molecules of water. So I can also write 2 molecule of hydrogen react with 1 molecule of oxygen, then 2 molecule of water vapors are formed. And for the formation of 1 molecule of water, half molecule of oxygen and 1 molecule of hydrogen is required. And you see the formula of water, that is H2O. And in 1 molecule of water there are 2 hydrogen and 1 oxygen atom. And these 2 hydrogen atoms come from 1 molecule of hydrogen. It means 1 molecule of hydrogen contains 2 hydrogen atoms. And half molecule of oxygen contain 1 oxygen atom. So half molecule of oxygen is 1 oxygen atom. So 1 molecule of oxygen will contain 2 oxygen atoms. So I will say oxygen is also diatomic and we should write it O2. Likewise, 1 molecule of hydrogen contains 2 hydrogen atoms. So hydrogen is also diatomic and we should write it H2. So from these two examples, we have decided atomicity of hydrogen and chlorine, and then hydrogen and oxygen. Now the fourth application of Avogadro's hypothesis, that is to determine molecular formula of a gaseous substance. Yani using Avogadro's law, Avogadro's hypothesis, we can determine even molecular formula of some gaseous compound. And this we will discuss with one example. Like you see, when nitrogen react with hydrogen, we know ammonia is formed. that is the Haber process. I written the word equation: nitrogen plus hydrogen give ammonia. And according to Gay-Lussac's law, one volume of nitrogen react with 3 volume of hydrogen. That you have to cram, you have to remember. Then 2 volume of ammonia is formed. Or I can write 1 liter of nitrogen react with 3 liter of hydrogen, then 2 liter of ammonia gas is formed. And now if we apply Avogadro's law, to 1 liter of nitrogen contain or may contain n molecules of nitrogen. 3 liter of hydrogen will contain 3 n molecules of hydrogen, and 2 liter of ammonia will contain 2 n molecules of ammonia. So I can write 1 molecule of nitrogen react with 3 molecule of hydrogen, then 2 molecule of ammonia is formed. And for the formation of 1 molecule of ammonia, we need half molecule of nitrogen and 3/2 molecule of hydrogen. And we know nitrogen is diatomic. 1 molecule of nitrogen contain 2 nitrogen atoms. So half molecule of nitrogen will contain 1 nitrogen atom. And we know hydrogen is also diatomic. Earlier we decided its atomicity. So 1 molecule of hydrogen contain 2 hydrogen atoms. So 3/2 molecule of hydrogen will be equal to 3 hydrogen atoms. It means 1 nitrogen atom and 3 hydrogen atom combined. Then 1 molecule of ammonia is formed. 1 molecule of ammonia should contain 1 nitrogen and 3 hydrogen atom. So its formula should be NH3. So using Avogadro's law, we have decided the formula of ammonia. That is NH3. I can repeat it. We know nitrogen and hydrogen react and ammonia is formed. And according to Gay-Lussac's law, when nitrogen and hydrogen react and ammonia is formed, 1 volume of nitrogen always react with 3 volume of hydrogen and 2 volume of ammonia is formed. Or I can write 1 liter of nitrogen, 3 liter of hydrogen react, then 2 liter of ammonia is formed. And 1 liter of nitrogen may contain n molecule of nitrogen. 3 liter of hydrogen will contain 3n molecule of hydrogen, and 2 liter of ammonia will contain 2n molecule of ammonia, which also means that 1 molecule of nitrogen and 3 molecule of hydrogen will react, then 2 molecule of ammonia will be formed. And for the formation of 1 molecule of ammonia, half molecule nitrogen and 1.5, yani 3/2 molecule of hydrogen will be required. Now we know 1 molecule of nitrogen contain 2 nitrogen atoms. So half molecule of nitrogen will contain 1 nitrogen atom. 1 molecule of hydrogen also contain 2 hydrogen atoms. So 3/2 molecule of hydrogen will contain 3 hydrogen atoms. And 1 nitrogen and 3 hydrogen atom will combine, and 1 molecule of ammonia will be formed. So 1 molecule of ammonia should contain 1 nitrogen and 3 hydrogen atom. So its formula is NH3. So today we have studied about Avogadro's law and its application. And before Avogadro's law, I told you Berzelius hypothesis, and that hypothesis was equal volume of gases contain equal number of atoms under the same condition of temperature and pressure, but that was found to be wrong, and that was corrected by Avogadro's. And according to Avogadro's hypothesis, equal volume of gases under the same condition of temperature and pressure contain equal number of molecules. Here we will solve one numerical problem. if I say there are X molecules of nitrogen in 1 liter at some temperature and pressure, and there are Y molecules of oxygen in 500 milliliter of oxygen at same temperature and pressure. What is the relation between X and Y? What is the relation between X and Y? So if I say 1 liter of nitrogen contains X molecule of nitrogen, 1 liter means you can write 1000 milliliter. 1000 milliliter nitrogen contains X molecule of nitrogen. So 1 milliliter of oxygen will contain X by 1000 molecules of oxygen, and 500 milliliter of oxygen will contain X by 1000 into 500, that is X by 2. X by 2 molecule of oxygen, and this X by 2 is equal to Y. So I can write X will be equal to 2Y. Because same volume of gases contain same number of molecules provided temperature pressure are same. You are given with 1 liter nitrogen contain X molecule of nitrogen, mean 1000 milliliter of nitrogen contain X molecule of nitrogen. So 500 milliliter oxygen will contain X by 2 molecule, and that X by 2 molecule is Y. So X by 2 is equal to Y, so X will be equal to 2Y. So this is Avogadro's hypothesis. Okay, today we will do only this much. You will repeat it and read from the book also, and if you feel some difficulty you can ask in classroom. Thank you.